Hello, very good morning. My name is Rahul Mansar. I'm from the Department of Aeronautical Engineering. And today's topic of our presentation is aircraft maintenance. So, what do you mean maintenance is basically? So, maintenance is keeping something in good condition is known as maintenance. So, things are like we are in day-to-day life, we are maintaining everything. We are maintaining ourselves. So how we are maintaining it? So maintenance is something to keep ourselves in proper condition. So the conditions plays the important role in the machineries also, in everything which is continuously working. So the various types of maintenance, if we are going to classify, is basically four types. So the first is preventive maintenance, the another is predictive maintenance, the third is breakdown maintenance, and the fourth is conditional based maintenance. So what do we understand by the preventive maintenance? We need to prevent the things. We need to prevent the things before its failure. For example, the things which we are using continuously, we are inspecting them, we are preparing the schedule of them. The scheduled task and inspection performed to them at a regular time of intervals to prevent the equipments and those components from failures is known as preventive maintenance. So in aircraft also there are some checks which need to be prevent after every flight or every span of time. We need to prevent them. So this is known as preventive maintenance. Then the another one is predictive maintenance. We monitor, we analyze the things before it fail. It gives us some signals. So from that prediction, we can assume that now this is a condition to make the maintenance. For example, a fan or its bearing, which is making a sound. So before it stop working, we are doing the maintenance of that thing is known as predictive maintenance. So the use of continuous monitoring the data analysis and IoT sensors to detect early signals of wear. So the maintenance can be performed before the breakdown is known as predictive maintenance. The key areas in aircraft predictive maintenance is we need to follow the proper procedures also for that. So I will share the another video lecture also in which what IoT sensors monitor aviation assets are and how they are working them and how this predictive maintenance play role into it. So uh, before that, the key areas of compliance in aircraft maintenance are we need to have proper documentation of it, record keeping of the crucial uh, areas. This includes the detailed logs of inspections, repairs, and maintenance activities to prevent from uh, failure. So these are the sort of things which came into regular inspections and check mandatory by FAA and EASA ensure the outgoing airworthiness. The FAA regulations requires that each part of the aircraft be maintained in accordance with specific guidelines, standards, and ISOs to ensure it remains airworthy. The next maintenance topic is breakdown maintenance. So, in this breakdown maintenance, This is also known as a catastrophic failure or sudden breakdown of an equipment or a component is also known as run to failure. While running, it suddenly fails down, breakdown. That's why it is known as a breakdown maintenance. So fixing the equipment only after it has already been stopped. Till then, the working as it is working, we don't need any maintenance of it. For example, our refrigeration is there, then refrigerator is there, then the refrigeration system basically, then the television is there. So we don't need a continuous maintenance, predictive maintenance, or preventive maintenance of it. We make maintenance when it breaks down. So this is known as basically a breakdown maintenance. Then the interesting topic of today is conditional base maintenance. What is this conditional base maintenance is? In the aircraft systems, and uh, we need to do the maintenance. We need to monitor the systems while it is working. So this is a maintenance is known as conditional base maintenance. In a maintenance strategy in which the health and performance of an aircraft or its components are continuously and periodically monitored, maintenance is carried out only when the actual condition of an equipment indicates that it is necessary, rather than to fix or flight hours intervals. We do it in the span or a period or a regular time in which the condition, based on the condition, we are doing the maintenance, whether it is required or not, then only. So it is a difference. This is a difference between a predictive maintenance and a condition-based maintenance. Prediction and the conditions are the both different things. Predictions are we are predicting from sound or something, but in conditions we monitor the parameters such as velocity, displacement, forces, uh, then its current, voltage, like that. And then based on that, we are taking the decision to maintain it. So a maintenance approach that uses real-time or periodic monitoring of aircraft systems to determine the current condition of component and predict the failures before they occur. So we are just preventing the from the approach of real-time or periodical monitoring so that the failure should be avoided. The next is the components. Which components do we monitor and how we can monitor? You can monitor the aircraft engine, the landing gear, the hydraulic system, fuel system, electrical systems, avionics, flight control systems, and airframe structures. So the first thing is when we talk about the engine condition monitoring, here is an example of sensored system for jet engine condition monitoring. So this is a aircraft, the aircraft failure keeps happening and we have caused hundreds and thousands of deaths. So recently there is an accident in Ahmedabad also. So the failure is due to the stoppage of the engine or failure of something we don't we, we can predict it. To ensure safety, the aviation industry imposes strengthened standards and implements frequent scheduling inspections, especially for the maintenance of engine. However, incumbent technologies do not completely eliminate the aircraft crash, but the jet engines at the heart of the aircrafts are not closely monitored in real time, and failures are occasionally unpredictable and invisible in the traditional inspection. So here The technology provided is like micro energy technology, novel micro energy technology, the rotational energy harvested and achieving self-powered and wireless monitoring of jet engines. So featuring maintenance, free power supply, and wireless communication. The new sensor architecture breaks the limitations of inaccessible locations in jet engines and solve the problem of the wire conditions and battery replacement. The key technology is the developed non-linear piezoelectric energy harvesters that can efficiently scavenge mechanical energy from engine rotation motions and convert it to electrical energy with minimal effect of engine normal operations. So these are the sensors from where they receive the data, they remotely work, they can manage the energy harvesting systems, the vibration, they check the vibrations. These are the wireless sensor nodes. Okay, so uh, so the objectives of CBM is improve aircraft safety and reliability, reduce unscheduled maintenance, minimum aircraft downtime, lower maintenance cost, increase component life, optimize maintenance scheduling. So these are some of the objectives of conditional based maintenance. And its working principle is very simple. We collect the data, we condition the monitoring, then there is a fault detection. If there is any fault detection, we diagnose it, we try to control it, and then the maintenance decision was taken. The proper maintenance decision was taken to recover the problem. So the data collection through the sensors such as temperature, pressure, vibration, oil quality, fuel flow, structure strengths are there. Just from these sensors, we collect the data. Then the data is continuously monitoring using the onboard systems or ground-based softwares. So then if there is a fault detection, the abnormal trends, if we consider a shaft, there is a looseness, there is a cracks on it, there is a imbalance situations are there. So according to the trends, we are capturing the the data and the deviations, and from normal operating conditions to the deviated, how they have deviated, so which problem is there, we identify easily. So based on that diagnosis, the maintenance engineer determine the cause of deterioration. So whether there is a lubrication problem is there, or due to the high temperature, this problem has been occurred. So how to control the temperature or forces acting on it due to the vibrations, due to the frictions, just need to know the cause of deterioration is. And then we predictively take the decisions how to maintain it or how to avoid this problem. So this is known as based on the conditions, the conditional based maintenance has been done. So the maintenance decision is performed only when required based on the equipment conditions. So the technique used in CPM is vibration analysis, detects imbalance bearing, wear and shaft misalignment, common use of engines and rotary machines. Oil analysis, detect metals, particles, indicating component wear, help monitor engineering and gearbox conditions. Thermography uses infrared cameras to detect abnormal temperatures, identifies overheating electrical components and insulation defects. Then ultrasonic testing is also there, detects cracks and leaks. Use of hydraulic and pneumatic systems are there. So we can use a MATLAB, and there are the tools also uh, by means of FFT, fast Fourier transform, and fast Fourier transform, and the wavelet transform. The signals which are uh, uh, which we don't want, those are present in the process, we can just declare them and what type of signals are there which we want, and from that the diagnosis can be done, and the problem can be solved. So there is a boroscope inspection also. Now the scopes are there. We can insert the scope in the inspection system. A visual inspection inside engines without maintaining checks, turbine blades, combustion chambers, and compressors. So the structural health of the monitoring can be also done. The sensors detect fatigue, cracks, and structural damage in the airframes. So the sensors used are vibration sensors, which are known as accelerometers also there. Temperature sensor, pressure sensors, strength gauge, oil sensors are there, humidity sensors are there, and acoustic emissions sensors are also there. So these are the types of sensors which can be used according uh, to the conditions, and from which we need to collect the data. The next is what are the advantages and disadvantages of condition-based monitoring? It includes flight safety, reduce maintenance costs, prevent catastrophic failure, reduces spare parts inventory, extended components service life, improves aircraft availability, enables predictive maintenance plan. So we can predict the life of the components also. If we are uh, having proper data collection and the proper use of proper uh, the details of that component, data and details of the component, we can predict the life of the component also. So how much we can use it, when to repair it, till when it can be repaired, and when it is to be replaced, we can predict easily. So the disadvantages are high initial, yeah, the initial cost is high, required advanced sensors and data acquisition systems. Complex data analysis is there, required trained maintenance personnel. Cyber security and data management challenges are there. So the conclusion is this: the condition-based monitoring system is maintenance system is modern maintenance strategies that relies on continuous monitoring sensors data and diagnosis to assess the health of the aircraft systems. By performing maintenance only when required, conditional-based maintenance enhances safety, improves reliability, reduces operational cost, and increases aircraft availability. It is a key element of modern aviation maintenance, and it is increasingly integrated with predictive maintenance technology, artificial intelligence, and digital twin systems too. So this is what use of conditional based analysis. So in the next video, we'll see again how the analysis takes place, which softwares we can use. So till then, thank you very much.